All right, I'm Dave Ratt, and this is the second video in a series I'm doing on terminating XLR mic cables and talking about various aspects of everything involved, from the tools we use, the cable types, and ways to optimize. And let's get started. So today, let's look at the different types of cables and different types of wire strippers. First, I want to show you the worst wire strippers you can possibly use. And that is these kind of add-on that they put in the backside of some crimpers that say wire strippers. They're just terrible. And first of all, they're not sharp often. And if they are sharp, that's not ideal. They're very rarely the right size, and they just kind of tear the wire up and don't do you a lot of good. One of the most useful tools I like to use is a pair of wire shears. These are general commercial electric, but any good shears, especially if they have a little cut hole in there for cutting wire, it's good. Extremely useful. These have some strippers in them. They're better than the ones on those, but I do not recommend using them. And the reason is you've got two sharp edges that come in from opposite angles and come around the cable, and ideally don't mess with the copper inside and cut just through the plastic outside. But if you're not perfectly centered in there, or those sharp edges come and they scratch the copper, any of those little wires, or in a solid conductor, the internal wire there, that little scratch, that little nick is going to be a weak point, and the most probable point that will fail. And you can try that. You can take a piece of solid wire and take a razor blade, draw a line on it, and then bend it, and it'll break right where that razor blade line is. So there's no reason to damage and reduce the reliability of the wires if we can avoid it. So not using these razor type is wise. Let's look at some other strippers here. Here's another version of the same thing. These ones here basically have two jaws that come down and grab around the wire, and then another clamp that clamps onto the jacket, and then it pulls them apart. And these things work pretty well. Again, I don't recommend them, but if you're doing low, you can kind of, very handy. So they can be very useful. Just be careful. You do not want to see, yeah, see I have a little copper bit there. So let's try that again. And I'm going to make sure you do not want to see any hairs or copper threads coming out of, and there's the end. And let's see, and we can flex these a bit. And we did a good job. We're not losing anything. Yeah, we don't need every one of them, but if you've cut a few, you've probably nicked a few more, and now you're down to a percentage. Now you have a weak point, and that is going to reduce the longevity and quality of your final product. Okay, so let's look at this. This is what we'll call a serve shield. And a serve shield is basically a bunch of conductive wires, thin wires, wrapped in a spiral around the inner core of the two wires on a mic cable. And mic cables typically have 3 conductors, but not all, and we'll look at some that have more. They have the 2 center wires and some sort of shielding to protect it from outside interference. The quality of the shielding can be quite important or irrelevant depending on the environments that you work in and the type of signals you're transporting. If you're transporting line level signals over short distances in places that don't have a lot of RF and radio noise going on, no dimmers and stuff like that, the shielding is does very little to affect the signal. On the other hand, mic level is extremely low volume, and it might be 60 dB quieter. Now 60 dB is 10 to the 6 times lower voltage, something in there. I don't know if that math's quite right, but it's a lot. A million times, 100,000 times less voltage. So because of that, when you gain it up, and you utilize it for mixing or the line level. When you gain it up to in the mixing board, it brings all the noise that it's picked up with it. If it's a balanced line, that'll cancel out some, but having good shielding is important. So having a serve shield, the advantage of them is that they're more flexible, they tend to be less expensive, and they're easy to terminate. And do some other things. So there's a inexpensive serve shield connector. This next one has a serve shield as well, and I've already stripped it, and you can kind of see the spiral there. And it's a there we go, nice copper serve. And if you, when you work with it, if you pull it off evenly, you can see, you get all the hairs. Now this is, I just said that mic cables have typically 3 wires, 2 center conductors and a shield. Well, this one has 4 conductors. It's got 2 blue and 2 white and a little center filler here that we'll cut off. Now what this is taking it to the other extreme. Instead of having, even though it has a serve shield, which is not the highest amount of shielding, what they've done here is they've used a quad core. And the 2 ways that mic cables prevent interference from, 2 of the ways they prevent interference is, 1 is blocking it with the shield, and 2 is to use a balanced line where you have 2 conductors with each carrying the signal. They can be equal and opposite, or they can just be, let's say, a balanced line. They're a balanced line traveling down, and the input looks at the difference between them, the input to the mixing board, and anything that's common to both of them gets canceled out. So that's called common mode rejection. So any noise that's induced will get canceled out. Well, if you have 2 wires that are just spun together, any noise that gets on one is almost exactly going to get on the other one. But the key word there is almost exactly, because there are 2, you theoretically could have a noise source that's a little closer to one wire more often than the other wire. By having 4 wires, then you've increased the probability that they're going to see the same signal introduced. The same amount of noise is going to affect both of them, and your cancellation will be improved. So they've added the extra wire. And also, with the 4 wires, it's more like a square. It's more round. So it's more uniform in its coming down the middle. And then you've got the serve going around the outside. So it improves rejection. So even though the shielding is not as high as it could be, the core and the balanced line makes up for that, or attempts to make up for that. Okay, so there's the quad. Let's take a look at another one. Should I use these strippers? Sure. And, okay, here's an interesting one. And this one barely has any wires on it. It's got a lot of very fine copper, but not a lot of, very fine copper, but not a lot of them. But we can see that there's a shiny foil that's wrapping around the center core. And this is actually a DMX cable with, and when you've put the foil around it, you actually get 100% shielding. And we'll see various forms of that as well, where what we'll do is let's go ahead and check this foil out. So I'm going to take my meter, put it on beat, and that's measuring at, let's beep, it should beep. Okay, so we can see that it's conductive, and the conductive aspect of it was facing outward towards the serve shield. So it's wrapped around this foil and providing 100% shielding, which is wonderful. The downside of foil shielding is it tends to make the wires more stiff. Now this one's stiff anyway. It's got a rigid, hard jacket to it. But in general, it makes it more stiff because you've got this kind of film around it instead of fibers that can move. Another challenge with foil shielding is flexibility, not only flexibility, but durability. If you take foil and you bend it back and forth, and it's wrapped around the wires, it stretches that mylar, the plastic that the aluminum is coated on. And it'll form little cracks over time, and you go the other way. And those little cracks will form little rings. And even though they're connected together by the serve shielding, they make little connections and disconnections, and that can turn into noise, and also your shielding degrades over time. And we'll see that with old snake systems. Now with snakes, we've got a larger diameter cable that doesn't bend on a very tight radius. And you've got a bunch of different foil shielded cables that can slide against each other. You know, it'll last a good long time, but the foil does tend to degrade over time, and it can become noisy. All right, so let's move on. Here's an install grade. Now, foil is excellent for install grade, where you get a very high amount of shielding. It's inexpensive and easy to work with. So I just stripped that off. The foil actually came off with the plastic surround, and this is ready to terminate. Okay. And the next one, I'll show you actually the strippers that I do like. So let's go ahead, and my favorite strippers, you know, not every tool works for every job, are these, they're kind of like a nipper. They've got a little grab, like a little fingernails that come out and grab, not sharp, but not dull, and then a friction part with some spines on it. And you put that in there, and when you, let's put it in, let's go this way. Put it in there, and it pulls the thing off, and it uses friction and grab. Now, the downside is it kind of deteriorates, and if it's a real rubbery surround on there, if the jacket's real rubbery, sometimes it'll stretch too much and not work. But for a lot of cables, it'll grab it, and it very rarely damages anything inside. And here we can see we've got a little bit of nylon or some sort of fiber, and then we've got our foil shield. Now this one, unlike the serve shield that was for the mic cable, the portable one, this has got the foil with the conductor pointed inward and a single drain wire instead of a serve shield. And this would be like an install grade, or a snake system would be, you'd see this quite commonly. Okay. Let's move on to, here is a braid shield. Now this is a copper braid. Now sometimes we'll see that it's copper colored, sometimes we'll see that it's kind of a white metal colored or tin. It's usually a tinned wire, so it's tinned copper. It's still copper, but it's got a metal coating on it to protect it and make it easy to solder, I guess. So this has got a braid shield. So when we're terminating a braid shield, we're going to want to separate the braids and do this again. I do this over a clean table. If you're seeing hairs, if you're seeing the conductors fall off as you do this, then you've done it wrong. You're messing up. You really don't want to see anything removed. And there we go. So there's a couple hairs off. So I would consider that pretty close to a fail. But I'm not being careful here. Another way to do that with braids, instead of separating like that, is to poke a hole in the side of the braids, kind of separate them out, and then pull the wires through. Now this cable is especially interesting because we've pulled it off. Now we've got a wrap, and then we've got some cotton fibers, which I will cut away here with my scissors. And cool. Now you can see that they're both black. We need to know which one's which. So why have they made them both black? And I've seen, and this is actually something to be really, I'm going to just score it slightly, but these tend to be, when you see that they're both black like this, or there's no differentiation between them, it's actually a very soft rubber. You can actually dig your fingernail in and pull them off. I'm going to use this stripper that I told you not to use because we're not going to go all the way through. We're just barely going to nick it there and just pull off the outside. And here we see we have red and blue. So why do they put this extra black jacket on there? Great question. Let's go ahead and meter it. It's probably doing something, and I bet I know what it is. So I got this set at 2K, so now we're going to see if we can get this guy to stand still. And that's with about a couple 3 millimeters or 1/16 of an inch between them. I'm measuring about 53 ohms. And I get closer to 34. This 1/2 inch piece is measuring about 220 ohms. So this is conductive plastic. It's a flexible material that conducts electricity. And so what they've done is coated these individual wires with conductive plastic that you remove off that would give them 100% shielding. Now, what I find interesting is you'll find 2 different types of conductive plastic, or many types, but 2 of the types of conductive plastic cables is you'll find ones that are isolated, where you've got the serve shield, and then there's a bunch of wraps or some sort of insulator, and then conductive plastic over the individual wires. And then you'll find ones that are more like this one we had with the serve shield over the outward-facing aluminum, where the conductive plastic is constantly shorting to the serve shield or the braid shield and providing 100% shield. So this one here, even though we've got shielding over each individual wire, these do not, I don't believe they touch each other, and I know they don't touch the serve shield. So we don't see any conductivity between the conductive plastic and the copper shield. It's open, and we can check, and there's no conducting. I can put it way high. Oh, yep, we are seeing conductive between the 2, but not to the outside shield there. So I'm not really sure what's going on with that, but it is a form of conductor. Now, one of the things you really want to pay attention to if you're terminating conductive plastic cables with conductive plastic ends, make sure you strip them way back down, because if you leave the conductive plastic all the way up, I've seen people not remove it, just look at the end to figure out the color, and it could be very close to the terminal. It can actually touch the cup of the connector and create a intermittent connection or create noise, because this is a conductor and you do not want it to touch anything it shouldn't be touching, and it should only touch ground. Cool. All right, next let's take a look at what else do we got. Okay, here is one that is a serve shield. A serve shield that we can see that's been tinned. It's got a silver color to it. And if we peel this back, we actually see a kind of an aluminum. It's not white. It looks like it's metallic looking paper covering the conductors. So again, none of this stuff is by accident. It's not just, maybe it is on some things, but rarely is this stuff on accident. There's probably a purpose that they spent money on this. So let's go ahead and check that out. And measuring the inside of this, I see, oh, there it is. Okay. Yeah. So we're seeing a very low resistance here. And without letting them touch each other, we see that it's not a great conductor, but it is, yeah, there it is. Okay, so we are seeing this is a conductive paper surround that is being used to increase the shielding. And the conducting was on the inside. It's against the wire, and it's not touching the serve. So it's a separate, isolated, just shielding piece that is not connected to ground, but it is a metallized paper wrapped around the internal conductors. All right, now we're going to get into the difficult to terminate wires. one of those wires is called the Belden 8412. Now I've pre-stripped this and I've also slit it with a razor blade. And we can see there's a bunch of hairs in there, a bunch of threads, multicolored threads. And as I peel them, you can see that the outer jacket is actually clinging to those threads. They're bonded to it. So I think they've wrapped the threads and then put the jacket around, probably because the jacket might, and then the threads do have some slip to them on top of the braid that we see here. And the reason that's important is the way that the different materials inside of a cable interact and slide against each other has an impact on the flexibility and the longevity, the durability of the cable. And so this one appears that the rubber is bonded to the outside, but I can I can move the jacket on top of the braid, so it does have some give there. And in here we've got a very tight braid. Pulling it back, we've got some burlap strings, and then this rubber here, this is almost like on a power cable, like on a SJ cable or an SJO rubber cable. It's got that real rubber. It's kind of oily feeling. Not oily, but very rubbery. Okay, so let's take a look at the other one, and I believe this one might be the 8412, but I'm not sure. And this one I have not slit yet, so I'm going to cut that with the razor blade. And typically cut a cable like this, but now this one, if I remember correctly, it's been a while. Yeah, again, it's bonded to it. Now here, instead of multicolored wires, we see this thing. Now this one here, these wires are not able to slide. I cannot slide the jacket on top of the braid. They are bonded together. It's been they've been merged or fused together. And here again we see a very tight braid. Now the braids tend to be, you know, in the 80%. They can be as high as 90 something. And then you start adding those other conductive plastic or foil, you get into the hundreds or high 90s. All right, so let's take a look at this. And for this one, I will spread this out. And this, you know, when you're terminating a bunch of cables, getting into this braid stuff where you're having to separate this stuff like this over and over again, this takes time, and it's really increases the amount of effort involved and cost. The reason I was bringing up the sliding of the cable and whether it's bonded to it, this, first of all, let me say this is one of the most robust cables. It is extremely strong. It's extremely durable. It's got this cotton. It's got a high pull strength. I mean, for a singer that just wants to, you know, Pearl Jam, Eddie, we'd use these for Eddie Vedder in early days of Pearl Jam when he was climbing stuff, and he would throw a mic cable. He'd throw his microphone up over the lighting truss and then feed it up until the mic dropped, grab the mic, sing into it, and then climb up 30 feet in the air on a mic cable. And for that, 8412 was the way to do it because this stuff is strong. All right, let's take a look at the inside. Now, I believe these, we're not even done with the fun part of an 8412. Well, it didn't happen here. There's actually wraps on these individual cores as well. This one didn't have it. I'm not sure. Maybe it's not 8412 here, but I remember the 8412 has the wraps on the 12s. All right, we're not seeing that. In any case, we don't. Bonding of the jacket to the shield. When the jacket, the rubber jacket, is bonded to the shielding, and you've got your connector, and your connector strain relief is grabbing the shielding, it's grabbing the cable and it's pinching it however it grabs it. Well, if the jacket can't slide against the braid or against the serve, when you turn that angle there, it puts a lot of stress on the metal wires right at the exit of the connector. And so you'll find that these cables that are, 10 years old, they've been around for quite a while, will tend to fail, right? They'll have a ring of broken shield right around the exit of the connector. Whereas if it can slide, it can distribute that stress, and the internals can slide and the braid can move. And while they may fail, they don't fail as consistently right at that exact point, at those grab points. So that was the downside of the 8412, which was an extremely robust cable. And there's a bunch of cables in that realm that have that high robust, high strength. All right, strippers, what else can we do? We could look at a couple more stripping bits. I will put this off. Here's another stripper, these ring strippers. This is a Platinum Tools. This is for Cat 5, Cat 6, but it also can work on cable. I'm not going to use it on that one. Let's try it on this one. And it can work on audio cable. And you can just go around and pull that off. These ones, again, if you've got these set properly, this one's got some, you can open it up and there's a little razor blade in here. There's 2 different heights. You can get ones that don't, since they grab around the surround quite a bit and the razor blade is in there, they've got a fixed depth which it can dig into. And if if it's set for a little bit lower than the total depth to get through, then the internal wires and the metal stuff you don't want to damage is protected. Here's a cool one. This one is comes in handy as well. It's also a Cat 5 stripper, but it works for a lot of things. And this is a Jokari, and it has a little set screw here, so you can actually adjust the depth of how deep the secondary one goes in. But that's for the smaller wires. The big one, let's give it a shot. And you can kind of see on a little measuring gauge, you can pinch it there and just twist around. And I typically like to bend it if I can, rather than pull it straight off so it doesn't break it up. So what I've done here is I haven't gone all the way through. And since I don't know this cable, I will, and I've done a bunch of, okay, so yeah, so you can pull this off, maybe. There we go. And again, no hairs coming off or copper wires is a good sign. All in all, let's give it a shot. We'll do one more bit. Let's give these, that to me. We'll just try all these cables with the friction grabbers. So I had to turn it and do it twice, but there's some mic cables, and we've done no damage to the cables. Oh, that one's got a little bit coming off. Although that has very thin wires. Okay, so yeah, all in all, these this kind of friction type cutters, and you can buy nice ones of these. They tend to be my favorite tool for stripping wires. We've gone over various cables, serve shield, braid shields, and conductive plastic, as well as foil, paper, and aluminized mylar. That should do it for this one. All right, that should do us for this one. In the next one, I will cover shrink wrap strategies, different ways to increase durability of the cable, and the advantages and disadvantages of using more or less shrink wrapped pins and connections. I'll talk about cable testing, failure types, how the cables go bad, and we'll look at a whole bunch of cables that I opened up that found various issues with that I recommend we don't manufacture with. And cool, that should do it. Awesome. So thank you for hanging out, and I hope you found this video and others that I do interesting and informative. And check out soundtools.com. Take a look at the products that I personally designed, some solutions for the pro audio industry, analog over Cat5, a bunch of testers, and other useful tools. Ratsound.com has got our sales department, rental department, install department. We sell a wide variety of pro audio and AV gear. We do installations, small to large, and we do rentals for everything as small as local clubs and backyard parties all the way up to Coachella Festival and artists like Pearl Jam, Jack Johnson, Blink-182. And thanks for hanging out.